Okay, so let's solve the open circuit short circuit, right? So if we had we have a circuit here, and we're going to ask you what the voltage of the open circuit is, right? And what the voltage of the short circuit is, right? So this is an open circuit, obviously. We open this circuit here, okay? And what is the voltage across? So if I wanted to open this, how do I do it? All right, so the voltage of the open circuit is the following, right? So what we want to do is we want to determine what is the I of the open circuit. Well, obviously the I going from here to here is going to be 0. That's all it could possibly be, right? Well, because there's no current flowing. So now the question is, well, I of OC0 of open circuit is 0 amps. Okay. So now what is the voltage across here? Like, what is the voltage across here? Well, if you do like KVL, and I'm just going to write KVL here, okay, and I'm just going to circle the second sign. So let me use a red pen real quick and circle out the second sign, okay, like so. And then, so what is this? This is going to be plus Vs, right? And obviously this is a VL drop here, right? So the voltage of the load. So plus Vs minus VL is equal to 0. So VL is equal to Vs, right? Pretty straightforward, right? So if our Vs value is 100 volts, then obviously our VL value would have to be 100 volts. So the voltage across an open circuit, right? Whatever you want to open, if you may create a voltage of the open circuit here, then that creates basically a plug or a load. So let's just say you have an item and you want to plug it in the wall. It is the open circuit, right? So basically, you can say that this is like a plug or load. You're plugging something into a wall, more or less. Now, what are the bad things about this? Well, if it's a wide open circuit, and this is, let's say, this is something small. But let's just say this is like, like, I don't know, 40,000 volts, right? So what's going to create here is you're going to create an arc flash, right? At a high voltage, it'll create what you call an arc flash. Let me write it again, arc flash, okay? And that is not good, okay? So in any kind of these high voltage areas, you want to wear it. So this is actually very dangerous, okay? So let's look at the short circuit. Well, how does the short circuit work? Okay, in the same view, let's analyze the short circuit. In the short circuit, I'm just going to close this circuit, right, across the load, right? And the way you want to do this is, what is the voltage across here? That's what I'm asking you, all right? You can do the current across, but you really want to do the voltage first. So if you study the voltage across here, what is the resistance here? So in this area here, what is the resistance? Okay, and we're going to call this R1. Okay, so R1 on a short circuit has to be 0, right? So if R1 is 0 and there's no resistance, then the voltage obviously has to be, on the short circuit, it's always 0. So the voltage of a short circuit is always 0. Okay, the current on an open circuit is always 0. Okay. So now, what is the current of the short circuit? Well, let's analyze it, right? So what happens is when you have a current going across, it generally what it does, it serves to bypass this resistor here. It'll just bypass this way. Well, this becomes negligible, okay? Now, if you don't want to do it that way and you want to do the equivalent resistor route, this is how you do it. RP is equal to R1 RL and R1 plus RL. So what is R1? R1 is 0. What is RL? That is 0 plus RL. So that is 0 over RL, which gives me what? 0. So your RP is now 0. That's your equivalent parallel circuit. So you redraw it to RP equals 0. Or there's actually nothing here. It's a short circuit. So technically, I'm running out of space. So technically, it really looks like this. Okay, there's absolutely nothing here. Okay, there's 0. Okay, so when you know this, when you understand this, okay, I'm asking you, what is the current across when I, what is that ISC? What is that value? Okay, and it's kind of all over the place. Well, the ISC is basically what we do is we take, if you look on the back, we use an extra piece of paper on this. You know, I'm just going to kind of work on this stuff piece of paper. That you have V is equal to IR. So I of short circuit is equal to V over R, right? Now, we don't know what the voltage is. We're going to see, this is our source voltage, so we keep it at VS. But our R is very small, okay? So how do we analyze that small resistor? Well, let's just take some numbers, okay? So let's just take the number, let's say our VS is 1 volt, and we have a very small voltage. What's happening, okay? So let's just say it's 1 over 1, then 1 over 10, 1 over 100, 1 over 1,000. So this is 1, this is 0.1, 0.01, 0.001. Okay? As you can see, the larger it gets, the smaller the current. So therefore, the opposite is true. 1 over 1, 1 over 0.1, 1 over 0.001, 1 over 001. So this is now 1. This is what? 10, 100, and 1,000. So the smaller this gets, the larger this gets. So if this is very small, okay, and that means it approaches 0, that means what? This gets exponentially large. So this becomes what you call almost an infinite current, okay, or very large current. Okay, and that's why the short circuit is so dangerous. Not only just bypasses, it'll bypass everything, but it'll create a very large current, and it will just it could be a tremendous fire hazard. So you got to be very, very careful.